Welcome to the Explainer. Today, we're diving into something called DINOv3, a really huge leap forward in artificial intelligence vision from Meta AI. And trust me, it's fundamentally changing how machines perceive our world.
Okay, so let's just jump right in. What you're seeing here is the promise of DINOv3. We're talking about an AI that can process images with absolutely incredible detail. And I don't just mean it can tell you there's a dog in the picture. It produces features that are sharper and just make more sense. It's almost like how a human sees. This level of what they call semantical coherence, that's the new frontier. But getting to this level of clarity was not a straight line. Not at all. In fact, as researchers started building bigger and bigger models, they stumbled upon this really bizarre problem. The longer the AI trained, the worse it actually got at seeing the details.
So, here's how we're going to break it all down today. We'll start with the big dream of AI vision, then look at this unexpected glitch that popped up, the absolutely brilliant solution they found, and finally, we'll get into why this breakthrough really matters. All right, first things first, let's talk about the ultimate goal here. The dream for AI vision is to have a machine that can learn about the world just by watching it, without needing us humans to sit there and painstakingly label millions of images of cats and dogs and cars. And this really powerful idea has a name. It's called self-supervised learning, or SSL for short. This was supposed to be the key that would unlock AI models trained on basically unlimited data from the internet, allowing them to figure out the patterns of our world all on their own. But as researchers started pushing the limits, scaling these models up to massive sizes, like the famous DINOv3, which had over 1 billion parameters, a really mysterious and kind of counterintuitive problem started to emerge. Now, this is where it gets fascinating. This chart shows that as the AI trained for longer, it got better at the big picture stuff, like classifying an entire image. That's the bar going up. But at the same time, it got worse at tasks that need fine-grained detail, like semantic segmentation. That's the bar going down. Segmentation is all about understanding an image pixel by pixel. So the AI was basically learning to see the forest, but forgetting what the individual trees looked like.
And this slide just illustrates the problem perfectly. Early on in its training, the model could see really sharp outlines and textures. But the longer it trained, its vision literally got worse. It became noisy and confused. It was like putting on a pair of glasses that got blurrier and blurrier over time. The researchers themselves confirmed it right in their report. And this wasn't some tiny bug they could just patch. No, this was a fundamental roadblock that was holding back the entire field of self-supervised learning, especially at a massive scale. So to fix this, the DINOv3 team came up with a really elegant and powerful new technique to repair the model's failing vision and teach it how to see clearly again. They called it gram anchoring. And you can think of it like this. It's like forcing the adult AI to go back and take lessons from its younger, sharper self. It literally anchors the model's understanding of details back to that early stage when its vision was still crisp, which stops it from getting lost in all that noise. So the process is actually pretty simple, but incredibly powerful. They'd let this giant 7 billion parameter model train, and right at the moment when the details started to get fuzzy, bam, they'd flip the switch on gram anchoring. And just like that, the model's vision gets repaired, allowing it to train for much longer while keeping those amazingly detailed features. Now, with this huge problem solved, DINOv3 became what's known as a universal visual encoder. It sounds a bit technical, but all it really means is it's a single powerful model that excels at a huge range of vision tasks, right out of the box with no retraining needed. And the results were just stunning. On the industry standard COCO benchmark, it hit a state-of-the-art score of 66.1 MAP. That MAP score is basically just a grade for how accurately it can find and identify objects. But here's the craziest part. It did this with a completely frozen vision model. That means it just looked at the image once and delivered these top-tier results without any specialized fine-tuning for that specific task. And it wasn't a one-off thing either. I mean, look at this. Across the board, on all these tasks that require that deep pixel-level understanding, like segmenting a scene or estimating depth, DINOv3 just set a whole new standard. It significantly blew its already impressive predecessor, DINOv3, right out of the water. So what's the real takeaway here? It's that the features DINOv3 extracts from an image are just cleaner, more precise, and they make more logical sense. It's this fundamental clarity, this lack of noise, that is the secret sauce to its incredible performance across so many different jobs. But here's what's really cool. The team at Meta AI didn't just build this one gigantic, inaccessible model and keep it to themselves. No, they made sure this incredible power was accessible to everybody in the field. They actually created a whole family of DINOv3 models at different scales. So what that means is there are smaller, more efficient versions that can run on everyday devices, all the way up to that massive 7 billion parameter original for all the heavy-duty research. And they did this through a really clever process called knowledge distillation. You can pretty much picture the giant 7 billion parameter model acting as a teacher, passing down its vast knowledge to its smaller student models. It's an amazing way to compress all that power into more efficient versions without losing much performance. Okay, so that's a lot of tech talk, but why should you care about a new vision model? What's the actual big deal? Well, because its impact goes way, way beyond just research papers and scoring points on leaderboards.
Think about it. Having a single, incredibly powerful, frozen model that's great at so many different things is a total game changer. We're talking about smarter robotics that can truly understand 3D spaces, way more advanced medical imaging analysis, high-resolution satellite monitoring. All of this is possible because you have this one robust, universal foundation to build on.
By solving this strange paradox of scale, DINOv3 doesn't just improve the AI we have today. It is kicking open the door to a future where AI perceives our world with a completely new level of fidelity and understanding. It pushes us to ask a really exciting question. What becomes possible when a machine doesn't just see what's in a picture, but understands the very fabric of it?